Hi and welcome back. So in the past video we talked a little bit about some different groups of elements that we have on the periodic table. We've got the alkali metals, the alkaline earth metals, the halogens, and the noble gases. And what I want to do in this video is talk a little bit more about maybe some other groups that aren't, or some other elements that aren't necessarily exacted or exactly divided up into columns of groups. And I also want to talk a little bit about some periodic trends. So the first thing to talk about is essentially what we have on the periodic table. And we'll talk about this in more detail in the future. I know I've been saying that a lot, but we will. But anyway, essentially what you have on the periodic table is everything over here, essentially, and I know that's the technical term, everything over here. And I'll just draw this line. So germanium, tin is on that side of the line, bismuth is on that side of the line, and we're also going to include in this everything down here. So everything down here in our what we're going to eventually call the F block is also included in this division making with this orange line. And actually, except for hydrogen. Hydrogen's not really in there. But everything inside of this orange line that I just drew is essentially some type of metal. So they've got different types of metallic character. And then everything on this side of the line is going to be some type of non-metal. Or actually, you know what? I'm going to make another line down here because there is a line right here that goes around arsenic and around tellurium and down like that. And essentially what you've got is all of these elements. So all of these elements, which I've kind of shaded in orange over here, these are essentially all metals. They're, except for I think mercury, and actually I think it's only mercury. Mercury is the only metal that's liquid at room temperature, but all of these other metals are solid. And they all have very similar properties. They're all shiny, they're all malleable, they're all ductile, they all conduct heat, they all conduct electricity. One of the things that we'll talk about a lot in the future is they all they all are electron donors, I think, except maybe I'll have to check on whether or not bismuth is. But all of these metals generally tend to give up or to lose electrons when they react, rather than anything over here, which I'm actually going to start shading in yellow over here. And I guess this kind of, well, actually no, I'll include the noble gases for right now, but anything over on this side that I've kind of shaded in yellow over here, generally these tend to gain electrons, and we'll definitely learn more about why that is in the future. But the important thing right now is to just realize that everything that I've shaded in orange over here is really going to be some type of metal, that everything in yellow over here is going to be non-metal. And then what we've got that I'm shading in blue right here, these are going to be known as metalloids. So that based on different, essentially that they have some characteristics there like metal. They've got some characteristics there like non-metal. And one of the things that we're actually, and you're actually currently taking advantage of right now, is that you can, based on mainly changes in environment, that these changes in the surroundings, or I think it's also the temperature that these metals are kept at, that they can change their characteristics. And specifically, I'm talking about their characteristics of conducting electricity. And I might have drawn over it right now, but this element right here, and I'll circle it, actually, you know what, I'll circle it in maybe magenta. This element right here is silicon. Silicon, and what this group that I've shaded in blue is known as are the metalloids. which are, they've got some characteristics like metals, they've got some characteristics of non-metals, and one of the big, characteristics of these elements is that they are semiconductors. They are semiconductors that, based on changes in, I think it's mainly changes in temperature, and we'll definitely talk more about that in the future, but based on different changes in the environment or changes in the metal, that these metals in some situations will conduct electricity and in other situations will not conduct electricity. And that property, particularly of silicon, is what is enabling you to watch this video, and our ability to harness that power of silicon's semiconductor characteristic is essentially what is I guess allowing you to watch this video. So anyway, I guess that's just interesting. I thought I'd point that out. So anyway, the big thing to realize right now is we've got everything in orange over here, and remember, we're excluding hydrogen. Hydrogen is not a metal, so hydrogen is on the other side of our orange line, but everything else in orange, and we're including all of this stuff down here. These are all metals, some type of metals, and we'll talk more about how we already named these two groups. We have the alkali metals, alkali earth. We'll talk about these. These are generally going to be called the transition metals over here, and we'll talk about that in the future. The important thing to get is just that these are all metals. These in blue are metalloids, and that these that I've shaded in yellow over here are all non-metals. So that's essentially what I wanted to get across in this video. I'm actually going to get rid of this layer real quick. And a couple of other things I'm just going to point out. So we've named essentially these two columns, right? We've named these two groups. So we've got this group right here starting with fluorine. These are the halogens. This group over here starting with helium. These are the noble gases. We've got one other name, essentially, that this includes carbon. There's this axis, and it goes down to selenium, and then comes up like that. There's a name for, I guess, these elements, which is inside this. Maybe I'll shade this in purple like that. There's essentially a name for this this group, and it's essentially called the non-metals. So the non-metals, although technically, I guess, you could say that everything on this side of this side of the orange line to the right of the orange line is a non-metal, but the oxygen group doesn't necessarily have a dedicated name or anything. So I've heard these elements referred to as non-metals. The other elements that we should talk about, and I guess I kind of talked about a little bit, but this block right here is eventually we'll start calling this the D block, but these are all metals. These are all metals in the D block, and these can sometimes be called D block metals. They're sometimes called transition metals, and we'll talk more in the future about why that is, about why they're called transition metals, and we'll see that what we're going to see is that specifically when we're talking about electron configurations, we're able to predict very well what type of electron configurations these elements are going to have. So these elements in the alkali metals and the alkaline earth metals groups, we're very good at predicting what type of electron configurations and how many electrons they lose. We're very good at predicting what type of configurations these elements have. With these metals, it's a bit more difficult to really predict what type of we haven't really talked too much about ions yet, but we will in the future. And it's a bit more difficult to figure out what the electron configuration of these metals will be when they react. Anyway, I think I have probably thoroughly confused you with all of that information. Hopefully, if that was too confusing, please leave me a comment, and maybe I'll try to post an addendum onto the video that'll maybe reduce the amount of confusion. In the next video, we're going to start talking a bit more about electron configurations, and I'll also give you an introduction to ions. So anyway, thanks so much for watching, and I'll see you in a future video.